Alright, I'm going to show you another example. This example is particularly interesting because there's two different ways of doing it. So, I'm going to show you both ways. First, if I look at this guy here, well, I know x plus 1, that's inside of the square root, so maybe that'll get me somewhere neat. I also see that this is an x up here, and I know that the derivative of this isn't going to equal x. But let's see what I can do. Let's just play with it. So let's take this, and let's say that u equals x plus 1. So u equals x plus 1. And then the derivative, du, well, that's just going to equal dx. Alright, so the thing that's going to be weird about this is that if I plug this information in, well, I'm still going to have x in terms of, well, x, and I'd really like it if it was in terms of u. So what I can do here is that I can take 1 and I can subtract it from both sides, and that's going to give me that x is going to equal u minus 1. Alright, let's see where I can go with this. Let's just have fun. Let's just plug it in, see what happens. So, this is going to become, well, x, that's equal to u minus 1, divided by x plus 1, well, that's u, so that's going to be divided by the square root of u, and dx, well, that's du. Now, I know this probably still doesn't look super nice to a lot of you, but I'm going to use a very cool, I always think that these math things are cool, a very cool fact which says that if I have a minus b over c, what I can do is I can break that up into a over c minus b over c. So I'm going to use that fact to break this up so it doesn't look like such a difficult fraction here. So, this is a little bit better. As u divided by the square root of u minus 1 over the square root of u du. Sorry, that's supposed to be parentheses. So, remember that if I have u divided by the square root of u, that's u divided by, well, that's going to be u to the 1/2, minus 1 over, well, that's u to the 1/2, du. And if I have this u in the denominator here, remember that's the same thing as writing that as u to the negative 1/2. So this is going to equal the antiderivative of, well, that's just going to be u to the 1/2, minus, and over here that's going to be u to the negative 1/2, du. So what that did is that it took this problem and it turned it into something that just looks like a power rule. So that's going to be u to the 3/2 divided by 3/2 minus u to the 1/2 divided by 1/2 plus c. Now don't forget, we want to clean this up a little bit, so we want to plug this x plus 1 back in for u. Also, dividing by fractions is weird, so remember that dividing by 3/2, that's the same thing as multiplying by 2/3. So, our final solution for this guy, in terms of x, is going to be 2/3 x plus 1 to the 3/2 minus, and remember, dividing by half, that's the same as multiplying by 2, so that's going to be 2 times x plus 1 to the 1/2 plus c. So this would be our final answer, right here. Alright, don't forget, dividing by 3/2, that's the same as multiplying by 2/3. Dividing by 1/2 is the same as multiplying by 2. And we didn't want our answer in terms of u, we wanted it in terms of x. So that's how we got there. Alright, now if you're interested in sticking around to see the other way of solving it, yeah, go ahead and do that. That would be great. Go ahead and stick around and see where we take it from here. Yeah. So, now what we're going to do is that instead of having x plus 1 equal u, we are actually going to have u equal the entire denominator here. And we'll see how that goes. So, equals the square root of x plus 1. So when we take the derivative of this guy, what we're going to have is we're going to have du equals dx divided by 2 times the square root of x plus 1. As well, what I'm going to do over here is see how I have u equals the square root of x plus 1? Well, just like last time, I would really like it, and over here I don't have like a nice x that I can substitute into this. I'm going to solve this for x. So I'm going to square both sides, so I'll get u squared equals x plus 1. Subtract 1 from both sides, and I'll get x equals u squared, oops, not plus, we're going to have that as a minus, so minus 1. Now I'm going to take all that information and plug it in. So what I'm going to have here is that, well, for this square root of x plus 1 and then this dx here, that's this over here, right? Only instead of that 2 on the bottom, oh, I forgot to move the 2 over. So I don't have a 2 over here, but I can just multiply both sides by 2, so I'll have 2 du equals dx over the square root of x plus 1. So what I can do is that I can replace this entire thing right here with a 2 du, 2 times du. And here, well, I have that x, but remember, I said I could re-express x as u squared minus 1. So that would be u squared minus 1. Alright, great. So now what I can do is I can rewrite that as 2u squared minus 2 du. Take the antiderivative of that. So remember that 2, that just hangs out in front, so it's going to be 2 u to the third divided by 3, oops, minus 2u plus c. Now remember, just like last time, it's in terms of u, but what do I want it in terms of? I want it in terms of x, my original function. So the solution is actually going to be 2/3. Remember, what did I let u equal? I let it equal the square root of x plus 1. So that's going to be the square root of x plus 1 to the third minus 2 times the square root of x plus 1 plus c. Now remember, when I'm writing a square root, that's the same thing as this raised to the 1/2 power, so I can actually rewrite this as 2/3 x plus 1, or I'm sorry, this would be to the 1/2, so this will become 3/2 minus 2 times x plus 1 to the 1/2 plus c, which is the same answer that we had before.